Okay, in this video, the second half of section 3.4, we're going to take a look at another measure of position, 2, here, quartiles and percentiles. And just as their prefixes state, we're going to take a look at hundredths, so which percentile are you in, or which quartile are you in? They're very much related, and so we're going to take a look at them one right after the other. First of all, percentiles. Percentiles are a measure of the location based on dividing a set of data into 100 groups with about 1% of the values in each group. So take the entire data set, divide it into groups such that 1% of the data is in each group, and that would be called a percentile. Okay? Each one of those pieces, and there will be 100 of these because there's 100% in a data set, right? The notation here that we use P sub 10 to denote the 10th percentile, which has about 10% of all of the data below it. So when somebody says, you might have heard this, oh, this person is in the 98th percentile of their class. What does that mean? That means 98% of the people in this class are below that person that are in the class, their grades or whatever, right? Or he is in the, when you take your kid to the doctor or you yourself go to the doctor and you look at your height, and maybe you're a very tall person, well, you would say, the doctor might say, oh, you're in the 95th percentile. What does that mean? That means 95% of all of the people your age are shorter than you, right, in terms of height. That's what percentiles mean, and that's what P sub 10 means, or the 10th percentile. That means 10% of the people are below you, which means that there's a lot more. There's 90% above you, right, if you're in the 10th percentile. Here's another example. We use P sub 50 to denote the 50th percentile, which has about 50% of the data below it, or above it, because this is actually the median. If you think about it, 50th percentile means you're halfway, and that means 50% are below the data point. You're at the median, or you are the median. Really quick warning here. To calculate percentiles, make sure you first list the data values in order. That's very, very important. List the data values in order so that you can go from least to greatest, right? Here's a picture to associate these. If you think about these, the ones that are taller pieces, right, are more narrower, because what we have to do is contain 1% of the population here, right? So think about this. Here's 50%, here's another 50% of the population. The ones that are further out are wider, right, because they are actually vertically shorter, but this would contain 1% of the population, right? This area right here, this wedge, if you will, would contain 5% of the population, and so forth. Okay, so those are percentile scores. So when we say you're in the 50th percentile, that means you are right here, and 50% of the data points, 50% of the people, 50% of the subjects in the experiment or in the study are below for whatever the criteria is, the height, the earnings, the grade, whatever the context is, right? And we're really interested in people that are usually on the outliers, right? For instance, if you're in the 99th percentile of, in terms of wages, that means you earn a lot of money. And of course, people compare this to national earnings, not just, a little couple people. So in terms of percentiles, we need to be able to calculate the percentile of a particular X value in a data set. And the formula for that is given right here. Take the number of values less than X. Number of values less than X. Please pay attention because I'm going to be asking you to do this on the quiz or test. And then divide that by the total number of values that you have and multiply by 100. Think about this. You're taking the number of values that are less than X, dividing by the total number of values, and that gives you a percentile, right, or a percentage of people below that value. So we can do these calculations right here. Notice, please, that I already have done the very important thing of listing the data points from least to greatest, right? So when we say find the percentile for the value 41, we first have to list all of these numbers in order from least to greatest. If they weren't, looks like they are. So to find the percentile of 41, I have to find all of the values that are below 41, and that would be 1, 2, 3, 4, 5. That's 5 for my numerator, number of values less than x, and divided by the total number of values. We have 1, 2, 3, 2, 3, 4, 5, 6, 7, 8. So 8 times 3 is 24, 25, 26, 27, 28. We have 28 values. So to find the percentile of the value 41, we would divide the 5 numbers that come before 41 by the total number of values, which is 20, what did it say? 24, 5, 6, 7, 8, 28, right? So we have that. Let's actually do that on a separate page here. So we had 5 values. The percentile of 41 is equal to 5 values that are below it divided by a total of 28 values times 100. And so whatever that number is, 5 divided by 28 times 100 will give you the percentile of your of the number 41. Now, I want to do actually one more here. There was a percentile of the number 89, right here, right? So this is very important that we figure this out. 89. Well, would you say that that is the 100th percentile? Because all of the data values are below it. And that would be the wrong answer, actually, because you are looking at and counting only the values below it. How many values are below it? If there's a total number of values that are 28, so total of 28 values here. How many values below it? 27. Below 89, excuse me. Percentile of 89 would be 27 out of 28 times 100. And please note that this is not 100% because 28 out of 28 would be 1 times 100 would be 100%. Why is that the case? Because the 89th, the person who scored 89 or whatever the context is, that is actually one of the scores, right? So there's no such thing as the 100th percentile. And that's why you will never hear in statistics, oh, he is in the 100th percentile. There is no such thing, because even if he was, he had the highest score, he's the highest person, tallest person, or whatever it is, he would be part of that data set, and he would be like the 99th percentile or the 99.9th percentile, right? You would have that person always be less than 100% if that was the tallest person or the value that is the largest here, okay? So please take note of that as well. So with this exercise, what we did was used this formula twice to find the percentile of a particular x value. Okay. It says here another thing that we would want to do is find the value of the 80th percentile. So this is like going backwards. We want to know, over here we asked, okay, given a value like 41, what is its percentile? But now the question is, well, we have a certain percentile, let's say the 81st percentile. Which one of these numbers would be the 81st percentile? And there are several rules that we have to abide by that are agreed upon by statisticians, and they're confirmed, obviously, just rigorous math, on how to do that. There's a formula for this. The location, think about this, the location of the value in the data set is given by this formula. K divided by 100, so kth percentile, right? 80th percentile, that would be 80. K would be 80. 80 divided by 100 times the number of values. So it's like going through this data set. Remember, they have to be written in order. And you're looking for, going through this data set, and you're looking for 80% of the data points to be counted. And then the next number will be actually the 80th percentile, right? And there's actually some nuances there about how to decide which number it actually is. So find the value of the 80th percentile. If we do this by hand here, we would have the location of the 80th percentile is given by 80 divided by 100 times the number of values that we have, which is 28, or 0.8 times 28 would give us a number. And I believe actually I might have done this on the next slide. Oh, I did it on the future slide. So I'll go through this. But remember I mentioned that there was actually a nuance to finding the kth percentile. And here's a little diagram to go about it. So it's very straightforward except for one slight change. So the first thing you do is to sort the data, arrange it from least to greatest. Okay, then compute L is equal to K over 100 times N, where N is the number of values and K is the percentile that in question. And then the question is, the location, L, is it a whole number? If it's yes, then the value of the kth percentile is midway between the Lth value and the next value in the sorted set of data. So you can find P sub k by adding Lth value and the next value and divide by 2. It's the average of the two. So you've seen this similar to finding the median, right? What do we do when we had an even number of values? To find the median, we found the middle two values and took the average of them. Well, that's exactly what we're doing here. What is the location of a particular percentile? If L is a whole number, then you want to include it, that number. And so you have to go to one greater number or something greater than it to make sure it is included. Whoop, go back. Well, that's weird. What did I just do? Okay, it's not allowing me to go backwards. There we go. Gosh, technology. Let's go back. So if L is a whole number, then what we're going to do is we're going to take that number, that location, and the next number next to it, and take the average of those. If the number is not a whole number, then just change L by rounding it up to the next largest whole number. So if it ends up being a decimal, just round up to make sure that you include that amount of percent below it, right? The value of P sub k is the Lth value counting from the lowest. So that's a lot of blah, 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 because I just spoke a whole bunch and there's some technical difficulties there for a second. But let me actually go through the process here. So I did the calculation here. Percentiles, same data set. If I want to find the 80th percentile, all I do is take 80 divided by 100, multiply by 28, and it's like finding the 80th place here. Well, the decimal point, or the calculation here, comes out to be 22.4, and because this is not a whole number, according to those rules that we just went through, we would just round up to the next whole number, which is 23. What does this mean? This is the location of the 80th percentile. The 23rd number in my data set, when my data set is ordered from least to greatest, would be the 80th percentile, which means that below the 23rd number, there are 80% of the data points are below the 23rd number. Again, think about what that means. 80% of the data points are below the 23rd number. Well, let's count the 23rd number. Here's 1, 2, 3, 4, 5, 6, 7, 8, right? 16, and then 24 over here. But we want the 23rd value. So the 23rd value would be 75. Okay? Hence, 23rd value 75 in our sorted list is the value of the 80th percentile. That means that we are guaranteed that at least 80% of the data points are below the number 75. And so if we count them, all of these numbers, the 75 would be the 80th percentile. Now you might count them and say, wait, I have more than 80th percentile, more than 80. It's like 81 or 82 or 80.5 or 80.75. That's fine. The idea is when we're calculating the 80th percentile, we have to be guaranteed that we have at least 80%. It could be slightly more. And so the 75, the number 75, is the 80th percentile because it has at least 80% for sure, 80% of the values below it. Okay. I will go over another example a little bit later on when we look at a whole number. What if the location ended up being a whole number? And in that case, remember, you just take the number and a number after it. So I take 75 and 76 and find their average. And that value would be the 80th percentile or whatever percentile. So let's now talk about quartiles, and then we'll do that example. What are quartiles? Well, instead of separating your distribution, your data points into hundredths, if you will, 1% in each of the slices, you're going to do the same thing but with 25%. So we have Q1, Q2, and Q3. And you've separated your entire data set into quarters. So we have the first quartile, the second quartile, third quartile, and here's the fourth quartile. You have a minimum, maximum, and Q2 is the median. Q2 is the same thing as P sub, think about it, P sub 50, right? P sub 50 would be the 50th percentile, which is the same thing as Q2. And Q1 would be the 25th percentile, because 25% of the data is below it, right? What would be Q3 here? Q3 is 75th percentile, okay? That's what quartiles are. And here we go. I just went through it on the previous slide. Q1 is the same thing as 25th percentile. Q2 is the same thing as the 50th percentile. Q3 is the 75th percentile. It's the same thing. Q1 and P sub 25 are exactly the same thing, and you do the exact same calculations to find those. So let's do that other example that I mentioned where we're going to end up with a whole number and see what the rules tell us to do. So it says here, find Q sub 3 in this data set. Now, please note it's a different color, but the ordering is exactly the same. We have all the same numbers here. So find Q3 means, by the way, what's percentile is that? P sub 75, right? Q sub 3 is P sub 75. And so I want to find the 75th percentile. The number, such a number in this data set such that 75% of the data points are below it. So let's do the calculation. The location of the 75th percentile would be given by 75 divided by 100, or 0.75, times the total number of values, 28, and that gives us exactly the number 21. It's a whole number. According to the rules, remember, we don't round this number up. We find the 21st value and the 22nd value, the next one, and we find the average of those. So if you take a look at 21st value and 22nd value, those would be the numbers 70 and 72. That's the 21st value, and that's the 22nd value. If we find the average of those, we have 70 plus 72 divided by 2 would be our Q3, right? The location of Q3. So 71, excuse me, not the location, the actual value of Q3. 71, which is not a data point, notice, 71 is the 75th percentile, or the third quartile. Please note that we had to take a larger number because we need to include this 70, right? Now that Q3 is 71, we would say, let's start counting all of the numbers below it, which would include 70, 68, 67, and so forth. And all of these numbers now would be 75% of the data. Okay, so again, if you get a whole number, find that location, find the location, and take the next data point after it and find their average. Their average will be the, in this case, third quartile, right? Or whatever quartile or percentile you're being asked about. So hopefully those two make sense. If it ended up being a decimal, just round it up, just round the location up. If it ended up being a whole number, take that and find the average between the two. And finally, let's talk about box and whisker plots. You might have heard about this. I wish they would look like maybe, some kind of animal. Sort of do. But here is a box or whisker plot in front of us on in the picture. And there are 5 values here that we're interested in. You might have heard about this. It's called the 5-number summary. And the numbers are the lower extreme, so the smallest value, the minimum value. Then we have the lower quartile, which is Q1. So 25% of the data points are between these two. So let's say this is somebody's tests, right? A class took a test and somebody got the lowest score of 60, right? They failed. Then the lower quartile, meaning this number was, let's say that's about 73 or so, right? 73, meaning 25% of the data points, 25% of the class got 73 or below. That means a lot of people passed, right? 75% of the class passed. Actually, a little bit more if you count 70 being the cutoff point, right? Because then you have these couple other percents here. But lower quartile, 25%, or Q1. The median is P sub 50, or Q sub 2. That is the 50th percentile. And that's where that is. That's like maybe 81 or so. So that means 50% of the data points, 50% of the students in the class scored below 81. And that means half of the people scored above 81. That's pretty good. And the upper quartile is the P sub 75, or Q sub 3, which looks like to be 90. That means 25% of the class scored greater than 90, right? Think about that. Or if you think about 75% of the class scored less than 90. And then our extreme value here is the maximum. Someone scored maybe a 99, or it looks like actually 100, right? So that's how you would read a box and whisker plot. And your calculator, when you do one variable statistics, at the very bottom of it actually gives you this 5-number summary. So it will give you the minimum, the Q1, Q2, Q3, and the maximum, right? Where remember the Q2 is the median. So you list all your values in the calculator under list 1, list 2, or whichever list you want, all of those under one list. And then you go to, according to our directions here, statistics, go to calculate, go to one variable statistics, and you would be able to get, along with your average, along with your standard deviation, at the bottom of the list, something called a 5-number summary. And what I'll do is I'll try to make sure that when we do statistics, when you take your first test, for instance, I'll do a 5-number summary for you guys and let you know so that you know which percentile, which quartile you actually scored in. Okay. Here's what I'd like you guys to do. You can create a box and whisker plot for the following data. It's exactly the same data set that we've been working on in this section. And so what you need to do is find the smallest number, right? That's pretty easy because I already wrote it greatest to least to greatest. Lowest number, find the greatest number. Those are your endpoints here. And then you need to calculate the Q1, Q2, and Q3. Draw a box around Q1 and Q3, and draw whiskers, or draw lines to the minimum values from Q1 and from Q3, from Q1 to the lower extreme, and from Q3 to the upper extreme value. So you can do this by hand. Pause the video and try it. Yes, it's going to take some time. That's okay. Finding the location of Q1, Q2, and Q3. We found a couple of those already. And then what I'd like you guys to realize, maybe this puts a smile on your face, your calculator can make a box and whisker plot for you. And here are the directions for you guys to do that. You go to Stat, Edit, enter your data set under List 1. Go to Second, which is the upper left-hand corner. Click the Y equals button. Go to Plot 1. Turn it on. And then among the different options, choose box and whisker plot with their outliers, or with dots, and then go to choose zoom and choose the zoom stat. That way the calculator actually knows, okay, you want to make sure I show you the box and whisker plot in the window, and then press trace to get the 5-number summary. Arrow over to the left or to the right to get the 5-number summary. That's awesome, right? Again, hug your calculator. Hope you feel a little bit better that your calculator can do this for you. And that's it for this section. We're going to take a look at probability, which tends to be the hardest chapter of the entire semester for some reason. So I hope that you guys are in tune. We'll take a couple of weeks to go through these next several sections in Chapter 4. But right now, please go to Section 3.4 and practice as many homework exercises as possible so you can solidify that information that you just covered. And of course, let me know if you have any questions.